Hello and welcome to this week's Focus on Geothermal Energy for the Weekend webinar, a partnership by Enerchange and ThinkG Energy. My name is Alexander Richter. I'm the founder of ThinkG Energy. And with me today is Erem Arikan, the drilling manager for Zorlu Enerji in Turkey. He will talk about the journey to the Kizildere geothermal field in Turkey. You have the opportunity to ask questions in the dashboard of the webinar, and we will after the presentation of Erem, be going through the questions as time permits. So ask your questions in the questions panel, and we'll try then to group and have them forwarded to Erem for answers. So with that, with further ado, Erem, the floor is yours. Thank you for joining us today.
Okay, thank you, Mr. Alexander, and I am very happy be with you, and it is a great chance, and thank you to all participants. I want to start a small anecdote. Yes, I am the drilling and workover and exploration manager for Zorlu Enerji, but in other side, I have a position named by my son. I want to give a small story. I have my son to take to Kizildere for a trip, and there was a huge steam from the cooling towers, and he was nearly 6 years old. And he started the school, and in a related session, his teacher asked to him, "What's your father's job?" And he said, he is the cloth maker, he is the cloth engineer. And it is wonderful story, lovely story for me. I want to share with you today. And today, as a cloud maker, I try to take you to have a journey to Kizildere geothermal field. And my presentation contents is I started with the early stage of the Kizildere geothermal field, the first exploration site, and then our Zorlu Enerji geothermal projects, some timeline, and specifically with the general information about drilling and workover projects. During the drilling, workover, and other projects, there are some troubleshoots, challenges, and a small brief information about funded European projects. It is conducted by the Zorlu Enerji and its partnerships. The last session, sustainability, environment, and question and answer session. I want to start a video from the 1970s. Yes, it's a small part of a documentary, and special thanks to the state-owned Turkish Mineral Research and Exploration Company officials. You can see here the first exploration site. It's a part of video, and we can continue the early stage of Kizildere geothermal field. The Kizildere geothermal field is a geothermal power plant located in the Kizildere village of Sarayköy district in Denizli province. It is in the southwestern of the Turkey. Also, Kizildere field is at the middle of ancient cities as Hierapolis, Laodicea, Aphrodisias, like this. Until the usage of Kizildere geothermal natural springs goes to 2nd century BC. Today, it can be seen that in the Pamukkale, Hierapolis, natural geothermal pools, bathrooms, and flow channels. The first geological and geophysical survey in the Kizildere geothermal field began in 1965, and were carried out by the state-owned Turkish Mineral Research and Exploration Company. And the first geothermal reservoir was discovered in 1968 with a geothermal well drilled in 540-meter depth, and it is nearly the 200 Celsius degree the bottom hole temperature. In these years, from 1968 to 1973, a total of 16 geothermal wells were drilled to depths ranging between the 370 meters to 1,200 meters. And 6 of these 16 geothermal wells were found feasible for the electricity generation. Today, we use these wells recently for the production activities. And then a prototype power plant began its operation with a 500 kilowatt turbine generator in 1974. The facility generated electricity and distributed it to households of the villages in the vicinity for 4 years free of charge. And in 1984, the state-owned company, electricity production company, built a power plant with an 18 megawatt installed capacity and put it into service. Between the 1984 to 28, they have operated with the 10 megawatt on average electricity production. And I want to give some global installed geothermal capacities. It is the total capacity you can see on the slide. Also now Turkey's capacities goes to recently 1.7 gigawatt only constructed in Turkey. It is the 4th of the world and the 1st of the European countries. And in other side, the 5 geothermal investors in Turkey, Zorlu Enerji, Mogan, it is other name, Yurmat Enerji, Çelikler Maran, and Grineco. Also, it is stated in all the south western part of the Turkey. Yeah, and then when we give a brief information about the project and timeline about the Zorlu projects, in September 28, Zorlu Enerji, a subsidiary of the Zorlu company, acquired the Kizildere geothermal facility from the Ankara electricity production company, state-owned company, with a privatization process with 7 other hydroelectric power plants across the country. Zorlu Enerji obtained the operating lease right for runtime 30 years. With the initiative of the Governmental Electric Power Sources Survey and Development and Administration, a research project was started by Zorlu Petrogas Oil and Gas Group. After 1 year, the Petrogas oil were sold to the other petroleum company, and then the project was carried out by Zorlu Geothermal Company. It is newly in cooperation with Hacettepe University and the Middle East University to increase the electricity production from the Kizildere geothermal field. Also, the Kizildere geothermal field now not only used for the electricity production, it is also, there's some district heating, nearly 5,000 houses in Sarayköy, and then there are greenhouses heating, nearly they product 15,000 tons of vegetables for annually, and then 500 degrees of vegetable greenhouses is heated by the Zorlu Enerji project. And there are 2 hotels, and there is a poor CO2 and dry ice production facility. We give all the NCG from our power plants. Also, you can see on the slide, it is the first step in 1984, the first geothermal power plant. And then with the start this time in 5 years, the Zorlu company constructed the Kizildere 2 geothermal power plant with an 80 megawatt capacity. It takes 5 years. Why? The exploration and drilling size, also studies on the new geothermal power plant construction projects. It takes 5 years, but after this time, after 20 it goes to every 2 years we constructed the other geothermal power plants. The power plants, the Kizildere 2 and the Kizildere 3, Unit 1 and Unit 2, it is a triple flush combined with the binary cycles, and you can see the capacities as the 80 megawatt and 165 megawatt. In other side, directly some detailed information. There are nearly 21 production wells and other reinjection wells were drilled for the Kizildere 2 power plant, and it is the net annual production capacity is the 450 gigawatt. And for Kizildere 3, it is the biggest capacity geothermal power plant in the Turkey and one of the in the European countries. Also, there are production wells and reinjection wells. Also, the cycle type is the triple flush and binary combined system, and it is the net annual capacity is the 1000 gigawatt hour. It is a new technologies. The using the triple flush also. Why it chooses the general? I think it is the very efficient and more efficient other power plant types. Yeah, it is the general situation and the future of the geothermal projects. Also, we have some expertise on the Erem construction procurement, business development, drilling and exploration sites. Out of the 1.7 gigawatt installed capacity, Zorlu with 4 also with the Alaşehir, totally 305 megawatt capacity power plants, and it is the biggest capacity in the Turkey. And some there are under development projects. There are 2 projects, Arikan and Arikan 2. It is related with the Alaşehir. It's the expansion. Also the Tekyamam and Kizildere. It is the total 85 megawatt in the expansion of the Kizildere project. And there are some other license. For example, I can say from the area, it is the east of the Turkey. We continue the new exploration for the new license around the Turkey. And before the drilling projects, I want to show a small conceptual model video for you. Yeah. Also, before the video, you can see some general lithology and formation of the field and a general map of the field in technical side. Also, this is the wells, the general formation and lithology. And it's related with the last scene is related with the geochemical modeling, also with the conceptual model you can see. And some faults, the main faults, and it is the general formation of the field. Yes. For the drilling and workover projects, I can give some highlights. The drilling project starts at 29 and finish at 2022 with the last makeup wells. It's only for the Kizildere 2 and Kizildere 3 geothermal power plants. For the expansion wells, there are nearly 30 extra wells will be drilled for the Turkiye and the Kizildere 4 projects. Now we have approximately 90 shallow and deep wells. It is totally 67 production and 23 reinjection wells. The shallowest well, our drilling projects, it goes to nearly 500 meters to deepest well is nearly goes to 4,350 meters. And in nearly 15 years, the total drilling activity in Kizildere out of Alaşehir, it is the 230 kilometers. And 80% of the wells drilled with the directional well type. Yeah. We can give this highlights. And then for the other slide, it's a big drilling projects. There were many troubleshoots, problems and other things, but the most important one is the higher bottom hole and circulation temperature. It is goes to like the, for example, the circulation temperature goes to 175 Celsius degree. And the low ROP of the formation, also the aggressive and abrasive formation we have in the metamorphics, all mechanical and differential stack pipe because of the faults and other differential pressures. Some directional drilling problems and unwanted lost circulation zones. And the project time is limited for the drilling because we have to finish the drilling, and then after test and other things, we can construct and we can make the capacity of the power plants. And there were very lack of drilling services at the start of the project. And in this case, maybe we can talk about the solving these problems. Normally the project started with the deviated wells, but after this time it was not economical because the oil prices, the directional services was too much, and continue to drilling project for the first 20 wells as a normal BHA out of the drilling, out of the direction drilling BHA, and the ROPs goes too much, and the drilling times for example 250 meter or sorry 2050 meters to 3000 meters, it goes to 90 days, 100 days like this, and we cannot match the cost of the wells became very much more than planned the investment rates. What we have do in this case, we take the all directional services for the last 80 for the last 70 wells. The direction drilling services is too expensive, and we have to reduce the drilling time for every section, for example 3 days, and totally 15 days for the match all the costs. But incredibly, we developed all the directional and other process in aspect of the bit. We started to use PDC bits. The capex side increased, but the total of the drilling cost reduces 1 to 3. For example, the total general, the 70 wells drilled in 50 to 60 days. And it means that in the total of the project, we cost saving nearly $70 to $80 million like this. And then other side, also we focus on the low ROP. I think we solved with these problems, use the higher developed bits, the PDC bits normally in the start of the project. Anybody cannot use this, but we use the highly developed. And then, for example, it goes to shoe nearly 1,200 meters for one well, and for the second well extra, these meters totally 2,500 meters. The section we drilled with the PDC with a general ROP in 10 or 11 meters per hour. It was very, very beneficial for us. And the field became an R&D center. We analyzing everything. We analyzed all the parameters, the results, and directly we change to develop for every well, decrease the cost and reduce the drilling times. And we make a successful job about this. And then other mechanical and differential stack pipe problem is solved by the mud and direction drilling problems also we have. It was a hard, very hard formation in Kizildere, especially in the metamorphics, the production side. How we solve the direction drilling problems, we developed all the motors, also the higher temperatures, the other problem for our BHA. We developed the new motors with the resistance to high temperatures, also developed some new techniques, for example, for the trips we cooling all time and other things. And then at the end of the project, the service companies coming, a geothermal direction drilling companies like this. And in the limited total drilling project time, every project, every drilling is finished by the nearly 15 to 18 months before the planned time with these techniques. Yeah. After a detailed process about drilling, for example, in the Turkey first geothermal coil tubing operation for well completion site, we used it. Normally, in the normal case, all the well completion operations was made by the rig, and for the trip time and other limitations, we have to use the new techniques for the well completion side. And then we go to service companies, the international service companies. We said to them, okay, we are running with a coil tubing. The first answer is their BHA and their equipment is not resistant to 200 Celsius degree or more than this. But in a few months, they developed the highly resistant coil tubings, and we make all the well cleanings, the acidizings, and other things in a very short time. In like the 3 days, we completed all the well completion jobs. And also first direction drilling, the geothermal well, 4 deviated well is drilled in Turkey, firstly in Zorlu project. And we have some S-type wells. It is the eliminated the risk of the the exploration site, and also we have a successful about the well type and other things. Yeah, there are great effort. All of the workers of Zorlu Enerji, managers and others, the 7 days, 24 hours, we gave all the efforts to projects. Also, it was very, very good times for us. I can say this. Yeah. And at the end of the drilling project site, I want to give some related funded European projects and partnerships. It is the most related, the funded, our drilling projects is the Deep Light project. It is funded by the Geothermal. And there are some other projects, for example, the GECO project is the NCG injection and decreased CO2 emission, and also Succeed projects, GeoPro, GeoSmart is all related with the subsurface works. Yeah, what's the Deep Light project? It is the revolutionary drilling technology is developed for uses the electric power instead of the mechanical and hydraulic forces. And with this electro pulse power, we trust in this. We make an efficient drilling, the more powerful drilling and reduce the drilling times. And we try to aim to change all the mechanical drilling. And we are at the end of the project. We take some, we take a good results from these projects, and we continue to develop the all these Deep Light projects and uses in the Kizildere field. We aim in maybe a small 1 year later we can drill with the electropulse system in our field. Yeah. Also, this is our partnerships for the research, for the projects, and we have many internationally universities, the companies, and the research centers and others. We are very powerful with these companies. Also, we add values with a broad experience from our projects. And in the future, we think about the develop some new projects, funded or not funded, and we try to all time support the development of the geothermal and other process related with our projects all time. We don't stop at this project sites because our company directly very support us about these research projects. And then I want to talk about the sustainability and environmental impact of the project. Directly supervising, as a directly supervising all the operations on the field, I can say this from the start of the project to end of the project. there were no hazardous and dangerous things for the environment and the socially. I can say this all time. We make the process, we make all the operations with a great attention about the environment. Also, it is policy of our company. Also, it is personally our policies. And then we have some zero carbon footprint forest projects, and the most important, the crucial thing is for me, for example, for the project, I can say there are many fig and olive trees in the Kizildere 3 GPP site. It is the 1,600 trees. Normally we have rights to take all the trees, but the company started largest transplantation application. We take 1,600 trees to take and replace to other side of the fields. And now 90% of these trees is live and they produce fig and olive now. It was very important and it was lovely for me. And then the other side, we have some biodiversity research and conservation. For example, you can see the heliotropium like this. It is the endemic flora, and our environment department found this plant, and now it is on a conservation site. In the biodiversity site, we are very have attention about the flora of the field, and we have other carbon disclosure and other projects. We have participated in Turkey and internationally. Also, we have many social projects during the Kizildere field. We have social projects about the education side for the school, and then many trips to our site. And all time we have many students, the intern students in our project for support the education side. Yeah. As the last slide of my presentation, the today's situation geothermal field, I want to give with a video also.
We have two infinite energy resources. One of them is right under our noses, the sun, and the other one is under the ground we walk on, geothermal. Geothermal. Maybe it's an unfamiliar word to you, but it has a very simple meaning. It's thermal water, steam and gas stored deep beneath the earth crust. Geothermal, the Earth's energy, is a natural resource that requires research, exploration, vision, information and experience. And the leadership of experienced and prudent investors is required to utilize this hidden resource beneath the Earth. Zorlu Enerji has been unearthing Turkey's geothermal power since 2008. Turkey's first geothermal plant, 15 megawatts, Kizildere 1. An efficient modern plant, 80 megawatts, Kizildere 2. A plant that stands out with its high-tech infrastructure, 45 megawatts, Alashahir 1. And now, Turkey's largest plant, 165 megawatts, Kizildere 3. Today, most of Turkey's geothermal energy production is carried out by Zorlu Enerji alone. Our target was to gain Turkey another modern, efficient, eco-friendly and sustainable geothermal plant. Kizildere 3 has two types of units that work in combination, flash power plant and binary cycle power plant. This system has a higher efficiency than the classic geothermal plants in the world. And the combined system used in Kizildere 3 minimizes the plant's environmental impact. As in every geothermal plant built by Zorlu, the geothermal brine gathered from the resource is re-injected back into the reservoir after powering the turbines via steam power. Geothermal, tomorrow's energy, is a completely indigenous and renewable resource. Thus, investing in geothermal to reduce foreign energy dependency means investing in Turkey's future. Following Kizildere 3, Zorlu Enerji, one of the industry's major investors, is working on implementing many other projects in the area. Geothermal not only means electricity, but it also provides added value to immediate surroundings of Zorlu Enerji. Zorlu Enerji gives the children who are the minds of tomorrow the key to the future by implementing different projects. Because our energy is for our children. Turkey's largest and most efficient geothermal plant, 165 megawatts Kizildere 3, is now operational. And thanks to Kizildere, the hidden power beneath the earth is in our lives now. Some things are much closer than we think. The right energy is very close indeed. Zorlu Enerji.
Thank you for your valuable time. Now, if it's possible, we can continue with the question and answer side.
Thank you so much, Erem, for your presentation and an overview on Kizildere. It's clearly exciting to see what Zorlu has built up in Turkey on geothermal, and Turkey as a country in itself, of course. But we have a few questions here. So I just kind of wanted to try to go through some of these, let's say, more technical questions here first. So one of the questions here is what the success rate of the drilling for Kizildere has been, in the sense of both positive outcome from the drilling. Do you have any numbers there or some kind of description kind of on the success rate in drilling?
Yeah, I have numbers about this. The successful rate is 98.9 of the wells. How can I say this? In the successful rate, how we comparison the successful in the drilling side. From the exploration side, they give us a directional path, and for the find the resource, for the find the production level, we have to reach to this depth and then goes a little bit more, and it is the successful rate for us. Only one well, also 503 meter, we left the well because of the unwanted the full loss. We cannot reach, but out of these wells, we finished all the wells in successful rates.
Okay, and then the next question.
Yeah, thank you.
Then here the question is from which geological formations you're extracting the heat here at Kizildere?
I can go to the geological site. In Kizildere, the lithology, general lithology, I open my notes, sorry for this. It starts with the aluminium site, and then the first reservoir after the claystone start with the mostly limestone. It is our first reservoir. Nearly we can see at the 400 meters to 800 meters. It is changed to some part of the field, and then after this, the formation starts. Continue with the metamorphics. The Menderes metamorphics. Also, there are marbles, sheets, quartzites, and other things. Also, it goes. There are 3 levels in this Menderes metamorphics. Also, it is mainly the old sheets, quartzite, and the last of the production lithology is the marble. And then in aspect of the reservoir type, we can say the liquid dominated geothermal reservoir. Also, it is coming in the origin from the meteoric waters. Yeah.
Okay, and then here the return temperature of the wells. I mean, you mentioned briefly the temperature, kind of, but at what temperature are you re-injecting?
We injected in the. It is all the exact numbers is confidential, but in approximately 110 Celsius degree we directly injected. But it changes in the power plant to power plants. It changes. But sorry for this. The exact numbers is confidential in the company side.
Understood. Then here's a question about the completion of the wells. Are these open hole or are these overall cased holes?
It is all the cased holes. We completed in the 7-inch casings, the slotted casings. Yeah, we don't leave the well without any casing because how we can say we think about this well completion site. It is the open completed wells, but there are some schists and other characteristics of the formation. We have to run in all wells the slotted casings in the production site.
And then the question here, I mean, I know that this is a bit sensitive, but you don't do stimulation of the reservoir, right?
After the drilling site, we stimulated with the coil tubing firstly for the cleaning all the drilling liquids and other some particles. Nearly for 12 hours to 24 hours, we stimulated wells, and then after cleaning, we take some tests. If we need make some acidizing or something else, and we use the old coil tubing the units for these operations.
Okay.
We use the nitrogen for the stimulation process also for stimulate the well. Yeah.
Okay. The question on corrosion at the wellhead or the valves on the surface, is that something that you experience?
Normally corrosion at the wellhead all time, operation to operation, and in a for example in 6 months, in 1 year site, we make some NDT process to the surface casings and surface the wellheads. Now there's a little bit corrosion. It is very small. It's not dangerous for the production or injection of the wells. there's no too much corrosion in our wellhead and our surface casings. Yeah.
Then another question here. The range of well diameters in production and injection intervals. And then of course then goes the question further, but yeah, first on the well diameters. What's the range here?
The well diameters is generally the 8.5 inch for the production side, but in the shallower the reinjection wells, generally we try to complete it with the 12-quarter section. Yeah, it is a little bit bigger. It is bigger than the one section than the production side, the reinjection wells. Yeah.
Then here a question on the typical flow rates. Do you have any numbers in for example, in liters per second or cubic meters per hour or something like this?
The flow, it is the flow range for the production side or the drilling process or the circulation side. I cannot take clearly the question. Yeah.
Although it is about the production, kind of how much production is per production well.
Yeah, in production case also it changed to well. It goes to, for example, 200 meter cube to 300 meter cube like this. It changes in all various the part of the field, and the well to well it changes.
That is cubic meter per hour, or what's the?
Yes. It is the general production of our site, not the recently. It is the average for all the duration of the production, starting until now. Yeah, we can give the average numbers like this.
And then the question here, the re-injection, do you need any pumps for that or some pressure? And if so, what's the energy that you required for that?
Yes. We use the brine injection pumps. We have to develop some pressure on the wellhead. But in some wells, directly it vacuumed, and then there's very low pressures in some wells. But in general site, in reinjection site, we have to develop a pressure on the wellhead with the pumps.
And that's then the question here. Do you experience any seismic activities around the geothermal field?
It's related with the other geophysical and the geochemical departments. Maybe we can send some mails, detailed mails, but they all time we have a big project with also the Turkish the Science Center. We directly measure all the seismic activities, microseismic activities from the field. Yeah, it is a continued project. It's not finished yet. We take all the data, the outputs, and then we are analyzing now.
So there's seismic monitoring around the fields.
Yes.
Yeah. Here a question, do you have scaling in the wells?
Yeah, we have scaling, but in generally, with the injection with the special chemicals, we try to solve these problems in this way. But the scaling now is not a big problem for us. At the start of the project, directly for the chemical adaptation, the geochemical department give very big effort with our service companies, and then at this point with special researches with the universities and all the laboratory studies, all the measurements, now we see the scaling, but not in a huge size like this. It is not problem for us for the operation and production side for us now. Yeah.
Okay. Are Kizildere 1, 2, and 3, are they running at full capacity at the moment, or?
It changes, but we can give the totally 1,000 gigawatt hour, maybe more, maybe a little bit less, but all time the annual the production rate is this. Also, the average is the 450 for the Kizildere too. It is the nearly the plant capacity we produce. Yeah.
Okay. What is the typical well spacing between the injection and production wells? I guess assuming then from the input below the surface.
In the drilling site, we use the shallower depths for the general type of the reinjection and production balanced. We drilled the middle shallow, not the shallower. It starts the shallower from the 500 meters to, for example, 200 meters. But in some cases, we have more than these depths. For example, it goes to 2,600 meters reinjection wells. But now, generally, out of the from the old project wells, our production wells is goes to more than the 3,000 meters. It goes to 3,000 to 4,000 meters. Yeah.
And is there any interference between the production and injection wells, or how do you monitor that?
Yeah, we monitor this with the tracer tests. From the start of the project, in some case, every 3 years, and maybe for some parts, every 5 years, we make the tracer injection tests for these interference. And there are many outputs about this. We know now which wells is very actively interference with the, for example, X production wells have interference, high interference with the Y reinjection well like this. Also, we know that generally, and you see in the conceptual model, we have a like this. There is measured by the tracer test. We have a model about this, the interference and other things. In aspect of the numerically, conceptual, and the geothermal models, we have detailed information about this, and there's interference between the wells.
Okay. Here, one quick question: what the non-condensing gases content of the brine is?
Yeah, NCGs decrease year by years. It is the nature of the geothermal fields. We can say not dramatically decreases, but in a normal range, I think it decreases. Yeah. But we try to make some NCG reinjection to reservoir. We have a with the European projects, European country, the partnership projects, also 2 of this, they reinjected the NCG to reservoir in a healthy way. With this, maybe we can balance this decreasing. Yeah.
Now coming to a bit more of international questions. Here a question is also on the technical side of things. Is Zorlu Energy monitoring new developments for closed loop or EGS projects? And if so, kind of what would be the opportunities for that in Turkey?
Yeah. Zorlu Enerji has now have more actively the projects about the EGS. But from the last 3 years, technically and practical side, we follow the bigger projects in international side. Maybe it is known that, for example, from the EWER, from the USA, there are many EGS at closed loop, and we follow these projects. and we calculated all the investment side, and if it will be the feasible, we think start to these closed loops for our fields or the other parts of the Turkey. I think the Turkey has very potential about the EGNSL closed loop systems. So we follow all the projects, and it is very the known projects by us.
Then jumping into this, I mean, there is, of course, I mean, seeing these international projects that Zorlu has been a part of, there are a lot of operators in there. There are technology companies, suppliers, academic research institutions. Does Zorlu generally is open for cooperation on certain aspects with international partners, or as well for example, for development in Turkey or elsewhere in the world?
Yes, it is the bigger company policy. We are all open about the researches and sharing data, and continue the development projects, research projects, or the direct the real the investment projects. We are very open. So the last slide, the previous slide, you can see our partnerships, and we try to make larger and make and increase this size with the all the international projects. We are very open for this. Yeah.
So, and is this both on a bilateral arrangement, so between Zorlu Energy and a company or institution, or do you prefer doing this as part of, let's say, EU projects on specific topics?
Yeah, direct both of them. Direct both of them, and if there is some detailed answer about this, I can redirect to our R&D department. We have a R&D department, and we are very open, and they conducted all these European projects and other projects. I can give the mail addresses after the presentation, after the webinar. Yeah.
So you might get a few emails, Erem.
Yeah.
Okay, then did you use any EU funds that helped financing exploration and the drilling, or is this more R&D funding that you received here?
Yeah, generally we found the R&D funds for the development side, and there's some in reservoir part. For example, also we can coming to for example, the Gecko, GeoPro, GeoSmart. This is all the exploration and production parts. Also, Deep Light is directly related with the drilling projects. Also, it is funded projects. In out of this, without any funded, but when the racing, we became some second projects, some third projects in Europe and in international area. I make here the funded projects, but there are many projects out of the funded projects we have.
Okay, I think
yeah,
then
thank you.
I think we're running out of time, but maybe then a last question looking into the future of geothermal in Turkey. We've seen, of course, a tremendous growth of geothermal in Turkey. But we've also seen that there's been, let's say, a certain standstill, at least for some period of time, due to the waiting for nearer tariffs and definition. But it seems that things are picking up again in the development. Can you confirm that? And how do the feed-in tariffs still are a large part in the development of the project, and how is heat increasingly being playing a role?
Yeah, I think I analyzed the geothermal in Turkey. It is dramatically a huge the jump to, for example, in 15 years, approximately in 15 years, it goes to 1.7 gigawatt. Also, I hope also in my analysis, in 5 years, I am waiting for the second peak for this. It is not related of the tariffs and other things. Maybe we are waiting a small balance for the general financial situations of the world, not in only Turkey, but the new proven resource now, the drilling starts again and again. Maybe not the whole size the last 15 years, but now there are many resources. Also, we try to find the new resource. With this, when we will finish the exploration site, I think maybe in 5 or 7 years, extra 1 gigawatt capacity we can conduct it in Turkey only in aspect of the electricity side. Also, there are many developed with the greenhouses. There are many projects about this. I think it is the very important part of the geothermal in Turkey. And then only we are in the southwestern. There are middle of the Turkey, the eastern part, the last session, for example, in the eastern part of Turkey, Ardiadin, we make some explorations, geophysics operations, and other, for example, some some shallower wells. I think the geothermal not finished in Turkey, but it will be more than now.
Excellent. And I think with that, we've run out of time. Erem, thank you so much for joining us today and sharing the great work of Zorlu at Kizildere and beyond. Thank you for sharing your insights and taking the time to answer these questions. I'm of course sorry that we didn't manage to answer all the questions, but luckily these are only a few here. But thanks for a very valuable input here from the audience. Thank you so much. We hope to see you at another webinar of ours in 2 weeks from now here with ThinkG Energy and EnerChange. And Erem, thank you again. And with that, we say goodbye and wish you a great weekend. Thank you, everyone.
Yeah, thanks to everyone again. And it is very grateful for us. And you support all the Geothermal International, Mr. Alexander. I appreciate it for this, and thanks to all the participants in your personal. Thank you.
Thank you indeed. Goodbye.
Goodbye.